Okay, welcome to today's Green Building Awards Winner Showcase, Willow Creek Affordable Housing. My name is Alicia Dolce, and I'm the Executive Director of the Connecticut Green Building Council. Next slide, please. We are a 501, a nonprofit 501c3, whose mission is to accelerate the healthy, resilient, equitable, and sustainable transformation of Connecticut's built environment. And one of the ways that we fulfill our mission is to offer programming that showcases a number of green certifications and high performance standards, including LEED, Living Building Challenge, and Passive House. One of our flagship programs is the Connecticut Green Building Council Green Building Awards, and it was created to celebrate the achievements of project teams working to transform our state and beyond. Next. Our call for entries for the Green Building Awards is open. Please submit projects and also nominations for green advocates and trailblazers. So you could see the registration deadline is June 23rd, and we're doing it in 2 parts this year, so it's quick and easy to register, and then the submission deadline is the June 30th. A little bit of session etiquette. This webinar is being recorded, and we're going to use the chat to ask questions. So as you think of them, please do put your questions or comments in the chat, and there will be a Q&A at the end for open discussion. We are offering 2 different continuing ed CEUs. We have a LEED specific for LEED AP Homes and LEED Green Associate. That is a self-report at gbci.org. And then we also are offering an AIA Health, Safety, and Welfare CEU. And if you're interested in that, we're asking that you please send your name, AIA number, and email address directly into the chat box. That way it'll be just one and done. If not, you can also forward that information to the email address that you see below, which is communications@ctgbc.org. I'm going to urge you to do it as quickly as possible, because the window for us to submit this information to AIA Connecticut is only so big. So either do it today, do it tomorrow, because we plan on sending that information over on Monday. As a nonprofit, we can't do what we do without our sponsors. We're so grateful to have Pella as our sponsor for this event. And Tim Baxter, who's the general manager of sales and distributor of Pella products for Connecticut and New York, and the general manager of the trade and commercial divisions, is with us today. Tim has over 15 years, hi Tim, of sales and operations management experience. And his focus is on developing long-lasting relationships with builder and architectural communities. You can see his email address there below if you want to get in touch with Tim to learn more about Pella for your next project. Tim, why don't you say hello?
Alicia, thank you. Thank you very much for the kind introduction. Thank you to everyone at the Connecticut Green Building Council for asking us to be part of today's showcase. Very happy to do a small part in today and making the program work. Congratulations to Laura, Michael, and the team at Kroski and the construction team at Viking Construction on your recognition today for the Willow Creek project. Both Kroski and Viking, you've been great partners to us through the years. And it's great to see the positive impact that you've made not only in Hartford, but also to the environment as well. So congratulations. We have a brief commercial to share right after this about our Impervia product line. This is Pella's Impervia fiberglass product. This is the product line that we've utilized at Willow Creek and other developments with Kroski and Viking. I think you'll enjoy it. There's some pretty cool features, both for residential and commercial, that would love to discuss with you guys more in the future about. So everybody enjoy the presentation today. Been through the dry run and learned quite a bit the other day from the team. So you're in for a good presentation, and thank you again.
Welcome to Stormy Heights, where the windows are always Pella, because the weather is always changing. Pella's fiberglass is the strongest material for windows and patio doors. They're tested from -40 degrees Fahrenheit up to 160. The fiberglass frame is even scratch and dent resistant. Pella windows, tested for extremes, designed for your home.
Thanks for that, Tim. Okay. It wants to play again. We've got 4 fantastic panelists prepared to share the success of Willow Creek with you today. Carla Butterfield is with Stephen Winter Associates. She's the Sustainability Director. We've got Laura Krosky, who's President of Krosky Architects, also being joined by Michael Weisbrod, a VP at Krosky Architects, and Mark Gendron, Professional Engineer at Acorn Consulting Engineers. And I'm now going to pass the baton to Laura, and she's going to take it away.
Great, thank you, Alicia. Thanks everybody for joining us this afternoon. Just a reminder, if you have any questions while we're presenting, please feel free to put them in the chat box and we'll make sure to answer them towards the end of the Q&A session. As previously mentioned, this course will have a AIA CEU as well as a lead CE with the learning objectives stated here. And as previously introduced, our team presenting here today is myself, Laura Krosky with Krosky Architects, Michael Weisbrod of Krosky Architects, who is the principal in charge of the project, Mark Gendron of Acorn Consulting Engineers, the MEP engineer, and Carla Butterfield of Stephen Winter Associates, who is the energy consultant on the project. So a little background on Willow Creek. This is an urban multi-phase redevelopment of Bulls Park, located in the Blue Hills neighborhood of Hartford, Connecticut. On the left-hand side is Bulls Park, which was built by the state in the 1950s. These brick barrack-style buildings were obsolete, insufficient, and dilapidated after years of neglect. Beyond the end of their useful life, the buildings were demolished to make way for the redevelopment Willow Creek. The master plan is designed with small-scale pedestrian-friendly buildings consisting of 3 to 4 dwelling units. And the buildings reference nearby neighborhoods to incorporate architectural design elements and follow traditional front yard setbacks to create walkable and lively neighborhoods. Of the multi-phase project, so far phases 1 and 2 have been completed, seen here on the right-hand side, and phase 3 construction is well underway. The redevelopment has been made possible through the strategic public and private partnership between the Housing Authority of the City of Hartford and JHM Group of Companies. The private developer support has provided finances and expertise necessary for the redevelopment and the creation of healthy, energy-efficient, affordable housing. With the experience gained from the development of several green building communities prior, the continued encouragement of funding sources, JHM made the decision to continue on their trend of green building. The inclusion of green building design principles into affordable housing raises the bar. These affordable housing developments achieve measures far above code to create housing that supports some of our most vulnerable communities. The big picture goals for the redevelopment include enhancing the quality of life for mixed income residents, from what you see here on the left, which is Bulls Park, to what you see here on the right, which is Willow Creek, by the way of healthy, efficient, low utility and low maintenance housing, as well as minimizing the development's impacts on the local ecosystem and strengthening the community through the contextually appropriate and sustainable design. Some of the challenges we met along the way included managing the balance between the project finances without the loss of healthy environments, building efficiency, environmental objectives, and of course, importantly to us architects, without sacrificing design. The site posed some of its own challenges, being that it's composed of mainly clay and silt. Stormwater management was a challenge that was addressed with a new detention system to infiltrate stormwater on site. And environmental issues associated with the removal of the existing 1950s housing was also a challenge we addressed early on. As you can see here, phases 1 and 2 are certified as Energy Star, Indoor Air Plus, LEED for Homes Gold, and the phase 3 is designed to achieve those as well, plus Passive House and DOE Zero Energy. The site is ideal in respect to its location and community linkage. Being that the site was previously developed, we were able to connect to existing systems and utilize the existing public transportation access, which provides 174 weekday rides. The design fosters social interaction through the close proximity to a playground, the Hartford Boys and Girls Club, and the communal greens and centrally located community building. We were able to score a 10 out of 10 points in the location and linkage category. And some of the most important sustainable building features include the high performance thermal envelope, which features continuous exterior insulation to eliminate thermal bridging, as well as low flow fixtures and irrigation, which save at least 35% over conventional designs. So using the Ecotrope energy modeling, the cost savings is about $230 per year per unit. And designing large-scale housing complexes to meet energy efficiency standards has a large-scale impact, as each unit here reduces greenhouse gas emissions by reducing CO2 emissions by 1 ton per year. With just phases 1 and 2 complete, this equates to 105 tons per year reduction. The model also includes a HERS rating index ranging from 51 to 53, which is at the PREA status according to the chart on the right. And as you can see here, older homes, like what was previously on the site, can be over 100, and even new homes built to code can typically be around 100. This is another instance where green building design elevates affordable housing to achieve standards above code. And for a resident population living below the state median income level, such savings from a semi-truck to a Prius hybrid make the affordable housing truly affordable. Another important consideration for affordable housing and the Willow Creek project in particular is the indoor air quality, as this plays an important role in the long-term success of a housing project. As a certified EPA Indoor Air Plus project, targeted construction practices and product specifications were used to minimize contaminants and pollutants. Committed to the residents' overall well-being, dwelling units also provide abundant natural light and large porches to encourage outdoor leisure. And now I will turn it over to Mike, who will discuss a little bit more about building the details.
Thanks, Lauren. Hi, everyone. Happy to be here today. So with a project of this size, there's understandably lots of details and considerations that are required to turn a dream into reality. And I'll just be talking about a few of those as they pertain to green building. The first thing I want to discuss is the selection of the exterior walls. But for this project, we only had a few options, given that the size of the buildings, coupled with the budget, forced us into the use of wood framing. And it's a very common construction method for multifamily buildings of this size. But there are several ways to take what I'll call a typical base level wood framed exterior wall that just meets code and improve it to a point where it contributes meaningfully to a LEED project. And these buildings are fairly small, as Laura said, 3 to 4 units apiece. So we had a high ratio of exterior wall to building envelope, which is all the more important to make this exterior wall system as robust as possible without breaking the bank. So initially we evaluated 3 different exterior wall systems, which I'll describe briefly here. The first option we evaluated was a zip panel. And for those of you who aren't familiar with what this is, it's basically a sheathing and continuous insulation system all in one. What makes this product so great is that construction time is reduced because you're able to install both systems in one operation. You just need to tape the seams afterwards. Now, the other benefit of this system is that because the insulation is sandwiched between the sheathing and the framing, the sheathing layers on the outside, which provides a standard nailing surface for siding, windows, and doors, etc. So the issue here with this particular wall assembly, we couldn't use it because of structural requirements, which precluded its use on this project. Our sheathing needed to be tight to the studs, so we couldn't have this product installed. If we did, we would have to install a standard sheathing layer first and the zip system on top of it, which didn't really make sense for us. So another system we evaluated was utilizing a hybrid insulation system, as you see here. In this instance, a 2-inch layer of closed cell spray foam in the stud cavities would be installed against the sheathing first. And then R13 bats would then be installed afterwards. This worked from a structural standpoint because the sheathing was now tight to the studs, but there were some downsides here. One was the fact that there was not a continuous layer of insulation. Even though closed cell spray foam has a high R value, it did not prevent the thermal bridging of the studs in this case. And the second was related to construction cost and sequencing. So given that there were 2 different types of insulation, they needed to be installed in 2 separate operations, and one of which was expensive. And just a quick note before I move on to the final one that we selected, this particular system met the funding requirements at the time it was awarded, but CHFA has since required a continuous layer of insulation on the outside of the building, and the design is not solely based on the R value. Carl will be talking a little bit more later about how the funding incentives and requirements have evolved over the years. So lastly, I'll go over the exterior wall system that we ultimately selected. This is the continuous insulation system that Laura mentioned at the beginning of the introduction here. In this option, the sheathing was installed tight to the studs, and then a separate layer of insulation was installed on top of it. So this met structural requirements and the budget. There was some downsides here too, nothing's perfect. This did require the use of picture framing and blocking around the windows and doors, which I'll get into in a little bit. Another major consideration of this project was the windows. One of the driving factors here was the U value and solar heat gain coefficient, so that narrowed our options. And I'll get into the selection of the actual window in a minute, but before doing that, one thing I'll mention is the importance of properly detailing and installing the window. You could have the best thermally performing window in the world, and it would be all for naught if it wasn't installed properly. Most of this comes down to good practice. We want to have low pressure foam around the window and the framing opening, as well as sealing and flashing the joints properly. This ensures continuity of the air barrier. And of course, sealing the edges is important as well. And also understanding the energy pathway in a LEED project is important as well. In terms of consideration of the required performance of the window. Because our window to exterior wall ratio on this project was less than 15%, that allowed us to use Energy Star criteria, or better, for the windows, and allowed us to use the performance pathway for energy. And lastly, I'll talk about the materiality of the window. While metal and wood are great from a durability standpoint, they have a high thermal conductivity, so they're not terrific in terms of performance of the frame. There are some options out there that are thermally broken frames, but those can start to get pretty pricey. And honestly, this project really didn't need the durability of wood or a metal window. So that led us to the study of composite windows, and ultimately we chose fiberglass over vinyl because fiberglass is generally more durable and dimensionally stable than vinyl, and we used pellet and Pervia windows here. It's really a great window, and I'm not just saying that because of who our sponsor is. We've used this window on many of our LEED projects. It's a really good quality window that met all of our criteria in terms of durability, performance, aesthetics, and cost. Pella is super to work with in terms of the service department. Another consideration I'll mention before I move on to some challenges is the importance of air sealing. something you'll never see if it's done right. But it's such an important aspect for green building. I'll go over a few areas of importance here. Obviously, the exterior envelope is the most critical area. So walls, roof assemblies, and the intersections of those assemblies, as well as the penetrations in them, need to be evaluated and sealed accordingly to ensure we have a good solid air barrier. And tenant demising assemblies are important too. You need to remember these as well. So same thing, the demising assemblies, the intersections, and the penetrations need to be evaluated. And the graphics you see here are all courtesy of Stephen Winter Associates from their air sealing guide. And we've included a link below that'll be available when this recording is done. So just to sum up a few things we considered for the selection of our systems on this project. Obviously, each project will have different considerations, but here we had structural requirements, cost and sequencing, durability, and of course the details. Big picture is important, but the devil is in the details, as they always say. So next, I'd like to talk about a few other project challenges that we face. I mean, the project of this size, there were a ton, but I wanted to narrow it down to a few kind of focus sessions. So first, let me explain the program a bit. As Laura mentioned, the master plan considered smaller, pedestrian-friendly, low-rise buildings with a target unit mix and density. So to make this project financially feasible, we needed to have buildings of this scale, size. So we had a height limitation due to the required aesthetic and density we were trying to achieve. So with a two-story building, that meant in some cases building conditioned space into the roofs of the buildings versus just using trusses to span over that. So here you can see an elevation of one of the buildings that has a lot of space built up into the roofs, which require building out dormers out of stick framing versus trusses. So this alone added to a little bit of complexity in terms of the design, given the geometric shapes we were trying to accomplish. But it also made for a very circuitous air barrier, a thermal envelope, as you can see in the diagram here. And there were lots of different jogs and different assemblies required, whether they be structurally driven or layout driven or otherwise. And each intersection of those assemblies needed to be carefully evaluated to ensure we had both proper R value and a continuity of air and vapor barrier. Another challenge I'll mention briefly, which is a pretty common design issue for this type of construction. I'm sure like some of you have probably seen a detail similar or identical to this before. These buildings are slab on grade, so we needed to employ a thermal break between the foundation stem wall and the slab. We did this by simply slipping in a 1-inch piece of rigid insulation between the two. And because the slabs are now kind of hanging and no longer bearing directly on the foundation stem wall shelf, we increased its thickness to provide a little bit of durability to that slab edge. And we were able to also increase our 2-inch underslab rigid insulation to that pocket, and design our foundation shelf accordingly. Another challenge that we faced here ties into the exterior wall system that I mentioned earlier. If you recall, we went with the exterior continuous insulation system, which required picture framing the fenestrations out of blocking, as you can see here, shaded in yellow. So, it's unavoidable in some cases. We needed a nailing surface. We were careful to minimize it only where we needed to do it. And that also played into the porches, as you saw in some of the slides in the beginning. We have a lot of porches on these buildings, so the structural connections from the porches to the building needed to be carefully thought out to minimize the interruption of that continuous insulation system you see. And give you a quick preview of Willow Creek Phase 3, which is Passive House. And the continuous insulation system here is 4 inches thick versus the 1 inch we had on the first two phases. And we're employing a special type of structural blocking called Armatherm on this project, which has a high R value and allows us to use it for structural connections to the wood. So I bring this up because it's a great example of how manufacturers in the building industry are developing newer products to meet the needs of green building. Everyone is certainly starting to take notice. And the last challenge I'll mention here is with respect to a funding incentive, which again, Carla will talk about in a minute. But at the time this project was funded, CHFA offered extra points for the funding applications if the development provided 33% of the site lighting offset by renewable energy. So with a project like this consisting of many buildings, as you can see here, needing quite a bit of photovoltaics for site lighting of this size, it didn't make sense for us to install multiple smaller arrays on multiple buildings and tie them together. It would have been incredibly complicated. So instead what we did was to employ a single freestanding solar canopy in the middle of the site, which is adjacent to our site lighting. And it also doubled as some shading for a few of the surface parking spaces. So with any photovoltaic system, it's obviously incredibly important that it be installed and commissioned appropriately, but also maintained. This was especially important here because of its proximity to the ground. Grass clippings and other debris can make their way up there easier than they would had it been installed on a roof. So it's important that the owner be cognizant of the periodic cleaning required to make sure that it's generating the electricity that it's intended to do. So that'll do it for me. I'm going to turn it over to Mark Gender from Acorn, who will go over some MEP systems.
Thanks, Mike. And unfortunately, I'm having issues with the video on my camera, my computer. So I'm really not that shy. And I think I've spoken in front of some people to this group before. So I'm sorry that I couldn't get my video camera going. Hopefully y'all can hear me. I just wanted to, we are the mechanical engineers for the project, Willow Creek, all three phases. And Mike discussing the envelope really is where we start with our design with envelopes calculations. You know, when you look at older envelopes, we typically would end up with calculations in a very higher range, in a 20 to 30 BTU per hour per square foot range. With this building, with the envelope Mike had mentioned, we are basically cut that at least in half, less in the area of a 10 to 12 BTU per hour per square foot. So we base our sizing on that. Now, infiltration rates, which are typically the highest aspect of what we look at, have come down greatly in the project as far as Energy Star being used and these methods for tightening up the building. So at this point, we are sizing and using two-stage furnaces for the project. It's very important. The project uses gas furnaces and gas water heaters in closets. Here's a picture of our design. You'll see the closet. It's centrally located, and we have a duct run that's between joists and around duct runouts opposite the joist through to diffusers. Again, it's a two-stage gas furnace, which is very important because the smallest gas furnace we can get is a 40,000 BTU. As you can see, the heating input range, the smallest they make is 40,000. So we need to get something. It's very important that it be two-stage, variable speed, and 96% efficient. It's very efficient piece of equipment, and this obviously will cut utility costs for the tenants. We also, in the same closet, have a on-demand water heater that I'll talk about a little later. Here is a graphic of the air conditioning unit, which is a mid-efficiency 16 SEER unit that was modeled by Carla and Winters and got us into the 50s, into the range for the HERS rating. As you can see from the picture, we have a closet there. That closet basically has the sprinkler and water service and fire alarm panel for the building. Moving on to the next screen, I want to talk a little bit on ventilation and what we have for ventilation for the buildings. Earlier designs really rely totally on natural ventilation and infiltration and intermittent bath fan use based on older building codes. Energy Star projects like phase 2 here typically are using a green bathroom exhaust fan with continuous run rates. There's switches inside the fan that allow you to set the exhaust rate um, for your occupancy and how many people that how many bedrooms and people you have. So that's what was used on phase 2. And this relies on infiltration, still relies on infiltration for makeup air, because we really aren't incredibly tight as we would be in, say, a passive house design where we would have to use an ERV. As you can see on the right is a picture of an ERV, which we will be using on phase 3 due to passive house. Passive house is 8 to 10 times tighter than Energy Star, and really it's mandated to use ERVs or HRVs. In this climate, you can slip either. HRVs probably would help you in the winter, but not in the summer. The ASHRAE 62.2 is the code we use, which is now in line with the building codes, pretty much in Connecticut, for requiring mechanical ventilation, either a system of supply, a system of exhaust, or a combined system of supply and exhaust. Again, phase 2 at Willow Creek uses a system of exhaust only, and phase 3 passive house will use the ERV with supply and exhaust and a very high efficiency core. The core is the heart of the ERV, and there are many manufacturers with very high efficiency cores that can be used. And if you look at design temperatures, you can end up getting an exhaust supply temperature when you're exhausting 70 of in the mid 60s, and that can be picked up by the HVAC equipment that you're using. You don't need supplemental heat for the ERV. The energy codes are now requiring somewhere between 3.5 and 5 air changes for the blower door testing. Again, I believe our buildings exceeded that in phase 2 and would greatly exceed that in phase 3, being passive house. In the phase 3 passive house, we will be delivering air into every room on supply and exhausting, obviously, from the kitchens and bathrooms. As you saw, we were exhausting kitchens and bathrooms under phase 2 with just straight exhaust fans, with the kitchen fan being just an intermittent fan. Passive house has a low energy target, requires ERVs to be used. And it's a separate decoupled system that is separate from the HVAC system. There are a few units out there that will combine the two. Again, on the domestic hot water, we have an on-demand high efficiency water heater, as you can see, and it creates enough hot water for the tenants. We haven't had any issues to this point. We also have a PEX manifold header system, which keeps the water runs very short and keeps the very low amount of water in each run out to each fixture, which is a water saver and part of the LEED requirements. Again, this is a 96% efficient on-demand water heater that was used in phase 2. Phase 3 is pretty much using all electrified per passive house with appliances. So in summary, the HVAC design requirements have evolved since we started phase 1 into phase 3. Building codes have caught up to Energy Star, and again, what we did here was much higher efficiency than energy codes, and again, we achieved the low HERS rating. So Carla will talk about funding agencies requiring Energy Star and the incentives related to it. And in the end, ventilation for us is much more involved now than it used to be. So at this point, I would hand it over to Carla.
Great, thanks, Mark. All right, so let's also look into how funding requirements, codes, standards, and voluntary certification programs have shaped the design, construction, and third-party verification for this project team's Road to Zero. Currently, there are 23 states and the District of Columbia having established economy-wide greenhouse gas emission targets. Connecticut's goal includes an executive order at the state level committing to reduce emissions by 80% by the year 2050. And our neighbors are fully engaged as well. It's not just California leading the way anymore. Massachusetts and New York have codes stretching to zero, with several municipalities recognizing the imperative to address embodied carbon as well as operational carbon. And the 2021 International Energy Conservation Code has a zero appendix, allowing states and cities to adopt a pathway to net zero. Originally built in the late 1940s for returning World War II veterans, this was the Allen O'Neill community in Darien prior to its 2012 redevelopment. At that time, CHAFA's Qualified Allocation Plan, the QAP, required Energy Star compliance, and there were only small references to LEED throughout the standards of design and construction. But JHM Development was intrigued enough about the New Homes program and committed to LEED certification. If you could back up one slide, Laura, please. At the time of design, CHAFA's QAP looked like this. Sustainable design points were not well formed. A project could even get 1 point by providing new natural gas infrastructure. Fast forward several years, and we see a push for all electric buildings with natural gas moratoriums in areas like Westchester County, Cape Cod, and Northampton, Massachusetts. Allen O'Neill became the Heights at Darien and a shining example of affordable housing in the community. It was Energy Star version 3 and LEED for Homes Silver certified, and the first stop on the project team's road to zero. Ground was originally broken in 1939 in Bridgeport, and the first public housing project in the state later opened as Yellow Mill Village. Renamed Father Panic Village, it slowly degraded and became a centralized point for crime and drug dealing in the 1980s. After its demolition in the 1990s, it sat vacant until plans for Crescent Crossings began. And this is what the QAP looked like in 2015. Better, but still not very comprehensive. The points and measures hadn't changed much, but the definition of high performance was beginning to take shape with the HERS index or ASHRAE savings as a baseline. At Crescent Crossings, also a Connecticut Green Building Council Award recipient back in 2017, JHM pushed the envelope, literally, to help achieve the HERS 52 target and projected performance significantly better than at the Heights of Darien. This energy comparison on the right reflects Crescent Crossings A. Phase B is built and performs even better than A, and Phase C is nearing 100% construction documents and will be Passive House certified. But the small increases in efficient envelope design, equipment and appliance installation, and construction techniques amount to savings more than a third in utilities as compared to the Heights at Darien. That's almost $1,000 per year per apartment. As we previously saw from one of Laura's slides, this was Bowles Park in Hartford before it became the Willow Creek project. At this point, the team had several Energy Star, Indoor Air Plus, and LEED projects under their belts, as well as the Heights at Darien, Crescent Crossings A, Crescent Crossings B. They were constructing the Royal at Darien, designing Windward Phase 1 in Bridgeport, and several phases at Willow Creek. Next slide. With Phase 1 and 2 completed and Phase 3 underway, the project team is cranking out these Energy Star, Indoor Air Plus, and LEED projects like a well-oiled machine. They will have completed nearly 550 housing units in about 8 years that perform at least 30% better than the respective codes under which they were permitted. However, it isn't just code that made some big leaps and bounds. We're now certifying under the more rigorous LEED V4 program and have seen big advances with CHAFA's QAP. This is what it looked like in 2017, with total points doubling from 3 to 6 for sustainable design, and Passive House earning half of those points. I think JHM, Kroski, and Viking would say they were happy to have embraced these programs early and find themselves ahead of the curve for both CHAFA and code requirements. And then on the right, the 2021 proposed QAP has even more rigor, with points spread across several options. So successfully implementing sustainability strategies is critical to staying competitive. Willow Creek 3 is under construction, and as we saw in a previous graphic from Laura, in addition to Energy Star version 3.1, Indoor Air Plus and LEED v4 Gold certification, it is also pursuing the DOE Zero Energy Ready Homes and FIAS certifications. Now, the only way to continue raising the bar and achieving energy, water, and resource reductions while increasing indoor air quality and occupant health and well-being is to reflect upon lessons learned. As Mike mentioned earlier, architects sort of refuse to design simple six-sided boxes. Apparently, they insist on aesthetically pleasing buildings with a sense of community appeal. Go figure. Therefore, we ended up at Willow Creek with knee walls, bump outs, and third floors built into the roof line. These are not easy to insulate and air seal. Another big step for the team moving forward is to comply with the DOE Zero Energy Ready Homes requirements, which means all ducts have to be inside the pressure boundary. The pressure boundary is inside the thermal boundary, but not necessarily inside active conditioned space. And a few lessons learned from early in construction of phase 1. Subcontractors will work quickly, but not always pay attention to details unless expectations are clearly defined. These images are from a November 28th, 2017 inspection. But corrections were made early on and set a tone for the entire project, making it easier to move from building to building and from phase to phase. It would be nearly impossible for the team to jump right into passive house level air sealing and insulation installation if they didn't have experience with Energy Star first. All of our hard work on the road to zero energy would be marginalized if we didn't also address occupant comfort, health, and wellness. While some things are harder than you might think, others are easier. We found that adding the Indoor Air Plus label to Crescent Crossings Phase A was fairly easy. So the team does this on all their projects now. That program builds upon Energy Star certification with requirements in moisture control, radon and soil gas mitigation, pest management, HVAC system installation, and combustion pollutant control. And while it's been a little difficult to get quantitative data, we know anecdotally that there is less missed work and school and fewer turnovers in healthy, affordable multifamily communities. However, it's a fact. We're all breathing unsafe air at some point during the day, be it inside or outside. And we can attribute high pollution levels with lower cognitive function. I don't know about you, but I really can't afford to lose any more brain cells at this point. So what can we do? Well, at least indoors, where we have a better chance of controlling the air we breathe, we can move away from combustion appliances. Although they're pretty, like in this picture, they are the source for higher levels of pollutants. And we can install better ventilation to quickly move contaminants from our kitchens and bathrooms, helping to ensure cleaner air. If you're interested, if you go back to the previous slide, Laura, there is a link there. If you're interested in where all electric kitchens are going, specifically induction cooking, watch this great demonstration video with Chef Rochelle to see what professionals are up to. And not only for our spot ventilation, but also for our whole house ventilation. Address filtration wherever possible, because it's not just dirt moving from surface to surface through our indoor air. While difficult to read on this chart, the lower bar is identifying the phthalates, phenols, flame retarders, fragrances, and fluorinated chemicals that are in our dust. With ducted systems, we can design in MERV 13 filters early, helping to ensure the air within our homes is filtered prior to recirculation. With non-ducted systems like mini splits, we can add room purifiers. And with HRVs and ERVs, we can ensure air entering the home from outdoors is well filtered prior to being conditioned and distributed through our fresh air ductwork. Why MERV 13? Because particle size matter below 2.5 microns directly affects our health and can be captured by MERV 13 filtration. And often those individuals in our affordable multifamily communities are the very young, the very old, and the most susceptible to chronic health issues. Another step to take with project teams to help ensure we're staying away from chemicals of concern is completing a table like this. We can analyze each component in the assembly and determine if the material complies with the standards and certification programs we're pursuing, and what is the exposure to the occupant, both short and long term, during the off-gassing. What's the concern to humans and the environment during the manufacturing, transportation, and installation process? And if we do substitute this product for one that is better for our health and reduces greenhouse gas emissions, is it as durable? This holistic approach to material selections is critical to the supply chain, construction sequencing, and lifetime of the building, as well as the health and well-being of its occupants. So I'm going to sort of reuse a quote here. All of our hard work on the road to zero is marginalized if we don't also reduce embodied carbon in our buildings. We focused a lot on operational carbon, but the embodied carbon discussion is still in its infancy for many codes, standards, and volunteer certification programs. This is partly due to the fact that we don't really have a readable products emission sticker, like we have, say, a food label or a car warranty label. Well, like anything, your shoes, your coffee maker, your car, reusing a building until its very end of life is the best way to reduce its embodied carbon. But a whole building approach is critical to integrating embodied and operational carbon savings. Why does it matter? Well, 28% of emissions come from the operation of buildings, but a staggering 11% comes from the embodied carbon of building materials. And while we continue to work hard to reduce operational emissions, more attention needs to be paid to the materials we are specifying to reach those operational goals. Yes, there are heavy hitters that we can focus on, concrete and steel and finishes like drywall and carpeting, but there are no real good guys and bad guys. It's all relative to the whole. And as a team, we look forward to implementing more embodied carbon reduction strategies in future JHM, Kroski, Acorn, Viking, and SWA projects. And we would love to see CHAFA include an embodied carbon analysis in future QAPs. Now I'm going to hand it back to Laura to wrap things up and move us into the question and answers session.
Great, thank you, Carla. And so in conclusion, I would like to address an often asked question. What about the Bowles Park residents? Many of those previously living in the Bowles Park community have moved into Willow Creek. Resident Joy Coleman, for example, in the top left-hand photo, was a Bowles Park resident of 26 years and is now a resident of Willow Creek, along with her daughter and granddaughter. It says she kissed the floor when she walked into her new Willow Creek apartment. Rose Pierce, in the upper right-hand image, was also a Bowles Park resident since 1986 and an advocate for her community, fighting for improvements, safe housing, and ultimately the redevelopment. She has also moved to a new Willow Creek apartment and spoke at the ribbon cutting. She's expressed being very, very happy to see her efforts realized. The full Hartford Courant article of their interview can be found at the link below. And as discussed here today, there's a significant benefit for the incorporation of green building design into affordable housing. This union enhances the quality of life for some of our more vulnerable communities by pushing the envelope where for many generations it has been acceptable to do the bare minimum. So thank you, everybody. I'll open it up to a Q&A.
Hi, I'm back. It's Alicia. That was fantastic. So inspirational. And I don't think I've seen a presentation that ended with the people, you know, the residents. And I actually felt like I was very moved that you included just some personal stories. So bravo to the entire project team. I did see you kind of answered one of my questions, which was the status of phase 3. And I can see now that it's under construction. And an earlier question, someone asked about site visits. And so I'm wondering now, with things beginning to open up and, you know, phase 3 is under construction, and of course you have a completed phase 1 and 2. Is it possible for people to visit the site? Have you thought of doing that? Or if not, can we tell us where it is and do a drive-by?
We did do a field trip visit out there maybe 2 years ago or so. So we have been able to coordinate that with Viking Construction. And if there's interest in that, we could look at doing that again.
Yeah, I think again, I think as things are opening up, it's always such a great teaching opportunity to be able to see things under construction. I know particularly with passive house, because so much of that is the behind the walls aspects. And what phase of construction are you with that?
So we're actually at a good point to look at that now. The buildings are being framed and we're just starting to get into mock-ups of their ceiling and window installation. So I'd say within the next month or so would be ideal.
Great, good to know. Okay, does anybody else either want to put a question in the chat or go ahead? You're now enabled to unmute yourself and ask a question of the team directly. So don't be shy. We've got 4 brilliant presenters here to share what they know and answer any questions.
Alicia, while we're waiting to see if there are any more questions, I will just say I tried to show the progression from all of the projects, but the 2 that we're very excited about right now are obviously Willow Creek, because 1 and 2 was not passive house, but 3 is passive house, and it is literally across the street, across the side street. So same community, and the same thing is happening down at Crescent Crossings in Bridgeport, where we have phase A and B already built and occupied for well over a year. And then construction will start on phase C after we get through they get through all their financing. So the takeaways for utility usage, and also the bigger impact that, like I said, is very hard to get our arms around, turnover and comfort of the occupants, are things that we're really excited about comparing between the different phases in both of those.
Yeah, that's the occupant comfort continues to be a question that's just looming on the horizon, begging to be answered. I was really intrigued that you mentioned Father Panic Village, because my very first home was like minutes away. So I know that section of Bridgeport very well. And I also really appreciated the progression of the QAPs, which you shared. But let's see, we do have, so there's a question in on wondering about any automation system to measure building performance, like utilities, electricity, water, gas, etc.
I can speak to it just quickly. There is no building automation system as the entire building, and they have not yet moved to smart thermostats. The programmable thermostats, the simplest possible, are what work really well right now in these residents, but that doesn't mean they won't be moving to smart T-stats. As far as monitoring or collecting the data of the utilities, we've been doing that directly through Eversource or UI for analysis of what's predicted versus what's being actually used.
Okay, great. And actually, since somebody asked about measuring building performance, so you mentioned occupant comfort, for example, and you're going to be looking at making those comparisons. So I'm very curious, again, how is that being set up in terms of the measurement of that?
So we had, prior to COVID, a survey ready to go for anyone leasing an apartment and as an exit strategy. It can be difficult with any developer, any owner of any multifamily, not just affordable, market rate, anything. University housing is a big culprit too, of not wanting to sort of look behind the curtain, because then sometimes folks think things that didn't happen before. So for instance, if you say, how often have you missed work since you lived here versus your previous apartment, they go like, oh, was my building making me sick, kind of question.
Yeah.
So the questions have to be posed very carefully, and then COVID definitely put a kibosh on us even getting any of those surveys out. So if anybody has any great strategies for collecting information like that, send them this team's way, because we'd love to vet them.
Yeah, that you make a lot of good points. Okay, let's see what else. Someone asked, and you touched on this, I think when you show the progression of the so the QAP is short for the Qualified Allocation Plan. That's just a vernacular that's used, and it's the blueprint, if you will, that CHAFA, also known as the Connecticut Housing Finance Authority, uses to allocate points for various project features. And so, for example, Carla was showing a progression of points from the sustainable design measures section. And it was fascinating for me to see how that has really evolved over time. And I think the question here from Chris is, how has the passing of supportable, affordable housing legislation and or perhaps even the evolution of the QAP going to enable you all as ACE professionals to do, more and better work? How does that impact? I guess, Carla touched on that. How is it really driving, what you do and what you sort of look to bring forward in a project?
Well, there's a lot of encouragement for our clients as well. So where we may be experienced and versed and excited about green building design, sometimes there needs to be a little bit extra encouragement for the clients as well. So it really promotes it on both ends.
That's great. I don't know if you're all able to see the chat, but I'm talking to you and I'm also looking at what people are saying. Mary Sanders said that she's really glad to see the emphasis on health of residents. She's a resident of Hartford and an environmentalist and would love to meet folks there for a tour. Keep her posted. Paulo Campus, who actually was a Green Building Award winner showcase 2 months ago, said data collection is definitely one of the biggest challenges. Indoor air quality requires measurement to be done regularly. Yep. All right. Any other questions out there? Does anybody want to ask about, let's see, we've touched on, anybody have any questions about the mechanicals? Again, I appreciated going through kind of the different lesson learns, what you kind of looked at for design and wall assemblies, and what you ruled out before you deciding what to rule in. Okay. It's Rathenbala has just said that specializes in building automation and can share info on data collection and performance measurement. That's great to know. Again, if anybody out there is so inspired to unmute themselves and share this themselves, go for it. Peter Millman says the Connecticut Builders Association is opposing legislation that would allow municipalities to adopt more efficient stretch codes. And in fact, there was an article that ran that was very frustrating for those of us who know how affordable housing works, because they cite that the work that you're doing is actually creating higher costs for affordable housing. And the question from Peter is just comments, speak to that issue.
I can speak to that briefly. With respect to affordable housing, it's not necessarily, it doesn't need to be more expensive than non-affordable housing if it's done right and efficiently. Obviously getting into more passive house and net zero energy end of the spectrum, there is some more initial cost with construction, but we're finding that the performance of the buildings and the savings in the subsequent years far outweighs that initial investment. So that just needs to be taken into consideration when talking about cost.
Yeah, so are you guys, and I see Paulo has his hand raised, and but I just want to follow up on that comment. Are you looking internally at your construction costs for these projects and sort of kind of doing a comparison to see, where things are going? Because the theory is the more, the next one is always, you discover efficiencies, for example.
Exactly.
Yeah. Because that's one of those other questions of just trying to get our hands on some actual data that can be shared to refute this sort of tired narrative that if it's a high performance or a green project, it's automatically, X amount higher. Paulo, are you able to unmute yourself and go ahead and ask your question and make a question, ask a question or make a comment?
Yeah, I think so. Can you guys hear me? All right. So thank you guys, Crosskey team, Carla, Mark, really good presentation. And I can certainly sympathize with a lot of what's been brought up here. As I mentioned, the data collection thing, one of the projects, or the project that we presented a couple of months ago, one of the questions was, how have these measures really impacted, in that case, health and wellness of the occupants? And like I mentioned, going back and getting hard statistics is really difficult. But we have had things like, the maintenance, anecdotal evidence about decreased rates of absenteeism. So, I would love to brainstorm when it comes to housing projects, when it comes to commercial or school projects. What are metrics that we can ask our clients as architects, as green building advocates? So in this case, maintenance, how frequently are they having issues with any of the mechanical systems, if any? How frequently do they change filters? What are they kind of finding? What are surveys that we can ask that don't feel onerous, don't require the smart thermostats, and may blur the line of it's my private residence and I don't want to give you guys any information. But what are things that we can do as a group that proves that these things do work and have a measurable positive impact over time? Because I think that will then backfeed into the concerns about it's too expensive, it doesn't work, this or that. Not really a question, but more of a plea for let's work together and figure something out.
I didn't mean, I was actually just typing a chat, but I was hearing, Paulo, that was, I like the idea of trying to create some sort of, I don't know, not a think tank, but like a round table where we just sort of compare and contrast, like it was fascinating to me to hear about like what Carla shared, what they tried, but then realized it's actually tricky terrain to just ask, to put together a survey, for example. So I don't know, but I guess I'm thinking out loud and wondering if anybody is sort of interested or intrigued by what Paulo suggested, just send a quick note in the chat and we'll see if we can even just put together some kind of informal follow-up. Could just be small group discussion. So that's a great idea. Okay, we have more people raising hands. Let's see. Well, Paulo, your hand is still raised. Do you want to make another comment or do you want to put your hand down?
No, but Zoom is locked up on me, so hopefully you can hear me. I'm trying to lower it, so.
Okay, well, that's so funny. We love technology. I think Peter, I saw your hand is raised. Go ahead and unmute yourself. I see you. Yep.
So here's another question along the same lines, which is, do the panelists and perhaps other professionals on the webinar think that current or past clients could be persuaded to, with a little help, weigh in with their legislators on this question of stretch code legislation? In other words, there are clean energy advocates making their thoughts known. There are professionals, some professionals. There are some, this Connecticut Green Building Council makes its thoughts known. But I think that we need to cast a wider net for those who are contacting legislators. And I just wonder, is there anything to the idea of getting clients to say, we're happy customers, we like this stuff, and it didn't cost us a ton of money more?
I don't know. It's an interesting idea. Anyone else? have any thoughts on that? Are you, Peter, are you talking about when you, well, at first I thought you meant maybe having, again, sharing occupant success stories. But then I thought at the end, maybe it's also talking to, you mean like the project owners, developers, people like that? You mean like, what do you think could, because those are definitely diverse stakeholders.
Right, and I was thinking more of the latter rather than actual residents, although residents wouldn't be bad either.
Right.
If there are homeowner associations associated with such projects, maybe they could weigh in. But I think that, but administrators, developers, people who can talk to legislators and say, what you're hearing from the Connecticut Buildings Association is not right, and that's different than presenting. Data, which is good. I like data, but I think that legislators need to hear from people.
Yeah, that's an interesting point.
Yeah, I agree. That is an interesting point, Peter. Something else to think about.
Right, but terrific project.
Yeah, it's incredibly inspirational. I have to say the before and after pictures are, I always say pictures, speak 1,000 words. It's honestly shocking to see, but in a good way, the transformation that occurred at Willow Creek. I mean, you must all be so proud of what you've created. And now that, you're moving on to phase 3, it's very inspiring. Thank you so much. So I think we're almost at quarter after. This has been a fantastic presentation and a follow-up Q&A. Let me just see if there's any last comments or questions. It looks like so far we're good. So last call. Does anybody else have any final closing thoughts? If not, we will bid you adieu. Oh, there is another one. Hold on. Let's see okay. Someone said, looking forward to hearing about phase 3. Thanks a lot. And Mary wants to know, this is a great question, actually, how many apartments?
In phases 1 and 2 combined, there were just over 100. In phase 3, there are 30. But when all said and done, when the entire master plan is built out, there'll be over 400 apartments, possibly up to 500 or so. So the project will be continuing for years to come.
Oh, that's very interesting. I actually was not aware of that. So Mary, thank you so much for asking that question. Are you expect to have involvement in future phases? Or
we hope so, yeah.
Yeah, that's awesome. All right, I think we're good. Thank you everyone for participating. Thank you again, Tim Baxter with Pella Windows. Thanks to all our presenters and our attendees. Chris will be posting this video recording on our website in our events library. So you want to go back and maybe catch a few things for the second time. It will be there. Usually we were able to get it up in about a day or two. So if not tomorrow, I would say probably by Monday. So thanks again, and everyone have a nice evening.